All right, so before that interruption, we wanted to see how we can use this set and get method on objects. Okay, and we saw that this is the encapsulation. Encapsulation provides facilities to easily manipulate objects like this. We are going to see a lot of technologies have been implemented on this. We have what we call persistence in the Java beans. We have persistence. We have also what is called hibernate. There are a lot of technologies that have been developed with the Java programming language that enable you to quickly write your program, to quickly develop applications. So there are default methods already that your NetBeans or those platforms, they call them frameworks, what they already provide to you, provide the basic codes for you, like the basic set and get method. Okay, so we are looking at an example of creating an object of type employee. We call it E1. Okay, and then for E1, we will set the salary. And for us to set salary, we cannot call this set salary method without giving the salary, not so. This is the message that this this method understands. Okay, the message is that when you call this, you must give the salary, maybe 1 million. 1 million. Like this. You call it with 1 million. Okay. When you call this method, this object, when you do this E1 and you set the salary to 1 million, it means that the salary of this object, what is it going to do? The method is going to take what you have given as the integer, and it is going to set this property of the object, which is salary, and say that salary should take the value, this salary that you just entered. Okay, and this is what is happening. And then it means that what if you now do something like E1 and you do get salary and you call the get salary method, this method does not need anything as parameter. It does not need any, it's a simple message. When you call this, you don't need any parameter. So if you call this method, what do you expect to be the output? Maybe the method will display something and you will have the output. You will see the output of that, of this, the salary of this object E1. You could have another object, maybe I created one. I could create another one, employee E2. Let me consider that E1 was Clinton, E2 is Evany or Bless. Like this. And then Clinton is a coordinator, so his salary should be less compared to the other people. So I also do E2 and I do set salary, and maybe I call their salary to be 2 million, like this. Okay, I didn't write well. $2 million. Okay, I can do E2 the same, like get the salary, and I'll be able to display the salary of these two guys. So now you understand that these are the objects, E1 and E2 are the same objects. They belong to the same class. They belong to the same class employee. But when you look at their internal state are not necessarily the same. This guy's salary is 1 million, this one is 2 million, okay? So this is what you can do. And this is the concept of that encapsulation. In this object, you have its variables, which are its values or its data, and you have the methods, which are predefined. Okay. So I believe this is clear to us. So in this first part of the lectures, it was essentially for us to understand the concept of message passing. And message passing concept is important for communicating with objects, inter-object communication. We first of all saw that some fellow researchers think that message passing should be considered as important as the object concept. It should be considered as important as we consider the object concept to be important in object-oriented programming. Because why? Without proper usage of this message on an object, without sending the proper message to an object, you will not use any method of that object. And I've given you typical examples with communicating maybe with third-party platforms, third-party applications, or external applications. You will not, an application or a company will not expose all its methods to the outside, all its functionalities to the world. Okay, the details of what is happening inside there is still blind to the external world, and that is the power of encapsulation. The details of what is happening within your objects is blind to the external world. You decide which methods should be used by the external objects, and you decide how they should use your methods, the kind of message they should send, the kind of message that you are going to respond to them. If they don't call you with the same message, if they don't send you the appropriate message, you don't react, you don't respond, as simply as that. So that these two concepts were important in our first part, okay? And I believe we have understood. So anybody has any observations or any worries, you can always raise them.
No,
Yes, sir. Please, I have a question.
Yes.
Does a return value affect a method? Like if you write a method, does the type of value you choose to return affect the method?
Okay. Like if you, like this method that we have here, we have the method set salary, right?
Yes, sir.
And set salary is responding only to float types.
Yes, sir.
Now, what if you call this set salary method and you are providing a string? Maybe you call the set salary, you do something like E2 set salary, and you put something like 2 million like this. Is that what you're asking, whether it will affect the method?
No, sir. Like after writing a method, you may choose to return, like you can decide to return 0, or you may decide to return any other value. So I'm asking if the value that I choose to return can actually affect the method. Maybe it can cause the method to malfunction.
No, it is the return value. The return value is trying to give like, what will you be expecting from the object? Okay. You cannot, for example, look, you have said that salary is maybe of type float. Salary is of type float. And then if you want to see a salary, from of an object, you'll be expecting that that salary should be returned. It should be of type float, not so?
Yes, sir.
The salary that you are going to receive should be of type float, because that is actually what is going to be stored in the database. So this control can be done for methods that are going to use, for other external methods that are going to use this get salary method. It is conditioning them that, okay, if you are calling this method get salary, be expecting that the type of value that you are going to receive is going to be a float value. You understand?
Yes, sir.
Yeah. So any external method that is calling this get salary method should be informed that the type of output that this method will give them will be of type float. So it means they should prepare themselves within the method. They should prepare to be able to use a variable of type float that this guy will provide to them. Maybe you wanted to get the salary and use it in another application. That application should be able to consume the output that is in the format float. Okay, so it is a kind of a control that you implement, and also a kind of information that you give to other objects that might want to use your function or that your method, that they should know that if you want to do this, make sure you understand that this is what it is going to give you. All right, so normally coming to this kind of one, like this one, like a method, you are calling a method with a different value type. Normally this method will not respond. Okay, why? Because the message is not appropriate. Look at what is happening now. When you look at 2 million here, the way it is written, it is text, not so.
Yes, sir.
It is written as text. So if this method set salary was defined as it is defined here, set salary was defined to only respond to float, and you are calling it with this, it cannot respond to this kind of message. And internally, you need to make controls. You need to make controls that what will happen to your program or to your object if somebody is trying to call with the wrong message. Your object should be able to respond to them politely that no, you are not calling them in the correct way. You should check. Yeah? You should not be calling them with 2 million written like this, but it should be presented in form of a float. Okay. So if you do this, you are using the wrong method, a wrong message. You cannot respond to this type of message. All right. Any other observation? Okay, so if there's nothing else, we are going to continue. So we have another powerful concept in object-oriented programming that we call inheritance. Inheritance, okay? From the name, when they say inheritance, you know what inheritance is. Some of you, you inherited some features of your parents, not so? That is inheritance. You inherited some properties from your parents, that is inheritance. You inherited some properties from your or from your grandparents, that is inheritance. And in object-oriented programming, the concept of inheritance is not too far from that one. So it means what happens is that you have a class. You have a class, and then you have another class that is inheriting some properties of that class. Maybe you have class A and you have class B. Class B is inheriting some properties of class A. Okay? It can inherit all of those properties of class B and use them exactly. When it inherits, it means all the methods that are in class B, it is going to inherit them. So that is the concept of inheritance we are going to see detailing. Okay, so that's why they say here that inheritance is the capability of a class to use the properties and methods of another class while adding its own functionality. Inheritance is the ability of a class to use the properties and methods of another class while adding its own functionality. So when you inherit your parents' features. You have your other personal features, not so, that are peculiar to you. Yeah. All right. So they give an example. We have employee records, like the employee records that we saw up there. We have employee record system. And we can create a generic employee class. And this generic employee class will do what? Will state the common actions that we have for all employees. We will state a common actions that are defined for all employees. Okay. And then you will have more employees that are based on salary. You have some that their payment is they have the commissions. And you have some that are paid on hourly basis, or hourly employees that maybe they just work per hour and they go. Okay. So, but you see that there is a class. You call all of them employees, but you will see that they have different features with respect to salary. So this can make you to create a superclass or to create some generic class that you call employees. And then you say, no, you need to create another subclass that you call salaried employee, another subclass that you call commission employee, another subclass that you call hourly employees. And all of these are employees, okay? We are going to see a typical example of that. For example, how can we put it? There is a simple example here that they are talking about cups, okay? Now you have a cup. There are different types of cups. We have what we call coffee cup that you use to drink coffee, for example. A coffee cup is an example of a cup. Maybe it is only specific that it is used to drink coffee, but it is a cup. You will see how it is defined here. Look, for example, you have at the top, you have your at the top here. Here you have your cup, right? Sorry. I cannot highlight an object. Okay, you have your cup here. And after the cup, you have what? You have a coffee cup. This is a coffee cup, and you have a tea cup. All these are examples of cup. All these are types of cup. They are types of cup. And then at the level of the coffee cup, you see that there is a coffee mug. A coffee mug is another type of coffee cup. And then you have the espresso cup. Okay. Now you will see that what? You will see that all these are cups. Like all these are cups. Tea cup is a cup. Coffee cup is a cup. Coffee mug, espresso cup. All these are cups. But you see, that's the relationship that you have here. A coffee cup is a cup. Tea cup is a cup. And then here, coffee mug is a coffee cup. And at the same time, it is also a cup. All right. So this is how inheritance hierarchy is in Java programming. Okay, I think we are going to see a kind of a typical example. It means that if you create a class cup, you can create a class cup with some basic features that every cup will have. Then you will look at, okay, coffee cup has some specific characteristic features. You will create another class coffee cup and you say it extends cup. It extends cup, and then you create another class tea cup that extends cup also. And this coffee cup can then implement some of its special methods that are peculiar about coffee cups. This tea cup will also implement some special methods that are peculiar about tea cups that are not necessarily found in coffee cup. And then here you will have also coffee mug will have some particular features it will inherit all these features of coffee cup. And if it inherits all these features, in turn is going to inherit all these other features of the big cup, okay? Because this guy will inherit all of his parent. This other guy will inherit all of his parent or of his superclass. And then this guy will inherit all from here. And if he's inheriting all from this guy, it means that in effect, it is also inheriting from this other guy. So it means that this guy is also inheriting directly from here. Okay, so that is the notion of inheritance. And this guy also can come directly to this guy because he is part of he is already inheriting from here and subsequently from here. Okay. So we will see how you will write, how you will create it. So at times the way you call it will be that a cup is a superclass. The cup is looked upon as a superclass, and these other classes are subclasses. So coffee cup is a subclass of a cup. Teacup is a subclass of cup. And this is the superclass. This guy is the subclass of this other guy. This guy is this other guy's subclass, and is also a subclass of the big cup. All right. So this is how in Java programming language, this is how you would define it. This is how you would define it. You will just say class cup, sorry. So you will say okay, you will define your class cup with the normal features that you have about cup, its instances or its states, variables, and the methods. And then you have class coffee cup, and you will say it extends cup. Okay, when you do extends, it means it is inheriting the properties of this guy, of this cup. That's why we say class coffee cup extends cup. Extends cup. Let me underline it. And this is the superclass. This is the superclass. And this guy is extending these properties. And then you have another subclass, coffee mug, and it is extending what? It is extending this other guy. Okay, it is extending this other guy. This other class, coffee mug, will extend this guy. Okay, so the key word that you will use in Java programming is extends. All right. Okay, now let's look at a typical example. Let's look at a typical example that we can run. Okay, let's look at, for example, a class animal. In the class animal, there are many animals, right? Are we together?
We are one, sir.
Okay. So in the class animal, what is happening? When Shu Abongwe is there, Evani will disappear. Are you rotating at the time Shu is sleeping? Evani is up.
There isn't one point.
No sleep.
And why did you come late to class?
No sleep.
Why did you come late, Shu? Huh?
Orange network. The reason the orange network is the network that is stable.
But I hope it is a little stable now. It is 10 p.m.
Yes, sir. That's fine.
Are you getting me fluently or it is breaking?
It's clear now.
It's fine, right?
Yeah.
All right. So let's look at a typical example of inheritance and inheritance hierarchy. We have actually seen what inheritance is. So it means when you are designing your applications or your systems, your objects or your classes, you will need to know which object is used or needs some properties that you have defined in another object. If you are creating a class, maybe from 2 students, or maybe you have a class students, as general, and then you say, okay, there are university students, there are secondary school students, there are primary school people that you also want to classify them in this category. Okay, now you can say, okay, students is a superclass. You will see that between university and secondary and primary school, they have some common features. Not so. There is something that is common between them. But now, okay, you can put all these things that is common between them, and you can look at these things, identify them, and create a superclass for them that you call students. And then you can say, okay, you are going to now separate them because you have also seen that secondary school, university students have some specific characteristics that are different from secondary school students, that are also different from primary school students. So what are you going to do? What you are going to do is that you're going to do something like this. You are going to create a public class that you call students. Public class student. What do you think are some common things that you have for all students? You can declare some variables. They have name. They have what? They have surname. They have what? They have date of birth. What else do they have? Date of birth is not integer. Name is not even integer. You can call it, let me just call it string. You have string name, you have string surname, you have date, which is date of birth. You have what again? What else which property do you think is common to all students of all levels? Primary, secondary schools, and all the like. You have maybe a string or char.
Address.
Okay, string address. We have also what again? Others you have. Okay, this is just an example. We are not doing and then you can have some methods. Okay, you can say, okay, you can say public void set name. You say it should take a string n, for example, and you say this n equals, our class is preparing to stop again, equal name. Now this name equals n. So you can define like this, and then you say, now there is something that you want to say university students are peculiar, then you can say something like public class university students. and you say extends what? Extends students. Okay. When you do this, it means that what? You will not need to be defined to redefine all these stuffs that you have defined in this class student. You don't need to redefine them. You just come now to specific things that are peculiar to university students. Because already when you define class university students and you say extend students, all these things that you have defined for students are already here. Okay. So you will just put now just things that are peculiar about university students, and you will do the same public class secondary school student. Let me just say sex students. And you say extends also the student class. When you do this, you know what you have done. You are going to define some methods here that are peculiar to secondary school students, same as you define some other methods here that are peculiar to university students. And you go to the same and you say public for primary school, you continue like that. The prime student extends students. Okay. And you also define things that are peculiar to primary school students here. So it means that what? It means that you have now what you call a superclass, which is the class students, and then you have subclasses for university students, a subclass for secondary school students, subclass for primary school students. Look at the advantage. The advantage here is that you are going to avoid repetition. You are going to avoid some redundancy. You will not need to come here and say all these things that you have. If you did not do this, for example, if you did not do this, it means that you are going to repeat all these stuffs here for university students and then add things that are peculiar to university students. You will come and repeat the same things for secondary school students and add things that are peculiar to secondary school students. You will come and repeat the same thing for primary school pupils before adding what is peculiar to primary school pupils. So you see that in one way you will have some redundancy. You will be doing the same thing, something that you could avoid by pushing what is common to them in this other at this other level and just adding a few that are peculiar to them. All right. So this makes also your programming very easy and makes it makes your programs easily understandable. Okay. So that is the power of inheritance in Java programming. So the example that we have here that you people are going to execute and run, that's the first assignment, is this one. We have a class animal, and we see that for all animals, they have a property, is that eat. Okay. They call the eat method for all animals, because all animals must eat. It is a characteristic of animals. Then you have a class dog. Dog is a type of animal. So what do? You say extends animal. Class dog extends animal. Okay. When dog extends animal, it means that automatically dog should eat because all animals eat. And then now what you do here, that you implement a method that is peculiar about dogs, which is bark. Only dogs bark. Okay, so you have this method back here that you give for dogs. If you do not do this, it means that inside dog you will have void eat. You see define this eat and you define the back method. And then we have another class baby dog. Okay, class baby dog. There is something peculiar about baby dogs that dogs do not have. And there is all baby dogs have things that a dog has. So what do? You will say that a baby dog will extend this dog class. class baby dog is going to extend the baby dog. So you are seeing a kind of a hierarchy in this case. And if the baby dog extends the dog class, in return, it is extending also, it is also inheriting all what is defined in animal, because dog is already inheriting or extending animal. So the baby dog should inherit or extend dog and in the same time extend animal. Okay, and then the method that is peculiar to baby dog is that it weeps. They weep. Okay, baby dogs weep. Dogs do not weep. Baby dogs bark. Baby dogs eat. So you see, there's an additional function or additional activity with baby dogs is that they weep. At the same time, they bark, and at the same time, they also eat. Okay, so once you define your baby dog, extending dog, know that it is taking all these other stuffs that you have defined for dog. Okay, then we have now, this is now a class. This is now a function to test this inheritance. You are now testing what you have implemented. So, and you know, in order to test in your testing class, you must have this, our main method. That is something that you need to always know in your class that you are using to test these classes. Check. Here you will see that there is no main method, but here you must have your main method because that's where the execution is actually going to be. And it is here that you are going to be creating objects. You will create objects in your main, in your testing class and in your main method. Okay, so that's why we have now baby dog that we call D is equal to new baby dog. And look at what is happening. When we create an object of type baby dog, object we call G of type baby dog, we can call this method that is peculiar to baby dogs weep. Okay, we can call this method back that is peculiar to dogs. See, back was defined for dogs, but just the fact that baby dog is extending dogs, it can use this method that is in dogs. And then baby dog can even use the eat method, that is found in the animal class. Okay, so this is the power of inheritance. This is the power of inheritance. So you see that baby dog is as you go down, baby dog becomes even more complex because it can call methods that are found at the highest class. But just being an animal, you cannot come and call weep. You cannot call bark. If you define something that is just an animal, it cannot call all these methods that are not, but all these guys below can call methods at the top. Okay. So this is your first assignment that you're going to implement and run, and you are going to do additional stuffs on this class. Okay. I think I should ask you to design this one also for students. Yes, delegate, take note. Our meeting is ending. When we come back, we will end. I think we have a couple of minutes to round up. Okay. Just be patient. We'll come back and then we will round up, please. I know Evanie wants to sleep.
Me too, sir.
Exactly, sir. I want to sleep.
So I don't want to sleep. I am the one who does not want to sleep, right?